Hey there, YouTube. Doc's Motorcycle Garage. Welcome back to the garage. So, where are we at in this? This is Saturday morning, Memorial Day weekend, and I think by now you should have seen the electrical system, aka ground video. It's not necessarily a part of this series, but it was a video that I mentioned, so I'm going to include that. I'm not going to make it a part of the series, but I'll put a link up right here, so if you did find the series and you want to go back and look at that video, go over there. What we're going to do today is we're going to progress into the wiring system of the bike, the wiring harness, if you will. So we're going to take a look at what we have laid out on the table. So we can see all this, Linda? Okay, cool. So this is your speedometer. This is your speedometer mounting bracket, or at least that's what I'm going to call it. And underneath it, I have a socket propped up. As you can see, this thing has been played with and worked with and tied into and tied out of several times. And I'm just not the guy to put that back in there. But if you did watch the electrical video, one of the things that I told you, and one of the things that you should know anyway, is anytime you're working on your motorcycle, disconnect one of the battery terminals. That's a homework assignment for you. You do not have to take both terminals off, but you do need to take one off, because with the frame grounded, anywhere you touch a metal object against the frame and a wire that has power running to it, you're going to get a spark. That's why they put fuses in there. Fuses are designed to prevent an electrical surge from screwing up stuff. That's why you have circuit breakers, not circuit breakers, what are they called? Bertie, those things we have that you, the strips that you can, surge protectors. Surge protectors. A fuse works the same way. What it does is it's thick enough to allow just enough of the amperage to pass through the wire that needs to pass through it, but it's not so thick that it allows enough to run through it without it doesn't allow enough power to run through it to run to something else to damage something. It's like an emergency level. But can you imagine having power to the frame and the electrical system, and then coming up in here and trying to poke around and take a screw out or something, accidentally touching these two screws at the same time, or anything on the bottom down here at the same time? So an ounce of precaution is worth a pound of what, Linda? Linda's mute this morning. Linda, say hey so they know you're there. And I'm not making up Linda today. So, speedometer mount, your dash lights, your accessory, ignition, run, whatever. Coming out of the dash, you have two looms. And the looms go back to the terminal block. Inside this terminal block, and this is what the terminal block looks like, what it basically does is, like number one right here on this thing, if you put in row A, number one, you might be able to run power into that, but what it does is it energizes that one and that one and that one. And this is just purely example. So you got numbers 1 through 11, and you got row A, B, C, and D. So you might be able to plug power into this right here, and then plug something in there, there, and there, and when power comes into here, it then moves on further to 3 other things. For example, you might power You might send power back to the horn button. You might send power to the rear brake light switch. You might send power to the neutral safety switch. Okay? That's how this terminal block works. It allows you to have, instead of having 3 wires coming down the loom with power on them, you have 1 wire that comes down. You might have the ignition switch in the off position. Alright? So then you turn the ignition switch to ignition. Now what has happened is a line came from the battery up through here to the ignition switch, and then it stopped. Once you turned the switch, you closed that circuit. Now you got power coming back down through here to 1 wire that plugs in here, but because inside here these 3 are joined together, you now got power going to, what did I say, the neutral safety switch, the brake light switch, and the horn button. So what that does is, by keeping this turned off, you don't have power coming to this all the time, and you don't have a drain on your battery. What you have here is you have this main loom that comes back and ties into the terminal block. Well, now we've got power that has been run up here to the front. Now once we turn the switches and give power to the rest of the bike, we have to get power to those switches. So you have 2 looms coming back to the front. Coming out of here, you have the right side loom and you have the left side loom. And here is your connection from the handlebar. And all these 2 is just plug in right here. And what that does, so here we go, we got 2, 4, 6, we got 7 wires in the right handlebar. You're thinking, my God, what's up there? Well, what is up there on your traditional Harley Davidson? At least a 1986. You have your start, or your run and off button, and then you have your start button, so that's 2. You have your turn signal, and that's pretty much it, I think. But guess what? You got to have wires running to them with power, and then once you flip the switch, the rocker switch, it makes a connection, and then the power comes back down the line, back down the tube, back into the terminal block, and from there it comes out another one of these, and it goes to the right turn signal. It goes to the starter solenoid. It goes to wherever it goes. Up here on the left side, we've got 2, 4, 6, 7 again. So what do you have on the left side? Well, you got a horn, you got your low beam power switch, you got your high beam power switch, and you got your left turn signal. Well, each one of those has to have a power in to energize the button. When you close the button, it completes the connection, and the power comes back down through here, back through this loom, back to the terminal block to beep the horn, to turn on the high beam, to turn off the low beam. So you got power coming out. When you got power going in, you got power coming out. It splits, goes down here to the terminal block. From there, it comes back up the back up the left side of the motorcycle, back up the right side of the motorcycle. But then, back here, you have your ignition loom. That's what I like to call this. This divides out. Now notice, so coming back, you've got wire coming into here, and you got wire going straight here. Because over here, you got a wire that goes to your coil. You've got a wire that goes to, I can't remember right now. You've got the wire that goes to your neutral safety switch on your transmission. You've got a wire that goes to something else. You've got a wire in the back that goes to something else. Over here, you've got a relay. Back here, you've got another relay. Back here you've got a ground that grounds to the bumper for the swing arm, and we'll talk about that more later. And still yet, you've got another loom coming out. This loom goes to your rear fender. It's real easy to take a look at your rear fender and go, oh, that's cute, and I really like the lights. But let's think about the lights on Hot Donna the way they were before this. You had a brake light, tail light running assembly, your big one, all right? Underneath that, you have a fender tip light. You had a turn signal bar. And inside each one of those signals on the bar, you had dual element bulbs. Okay, so what's a dual element bulb? A dual element bulb is like your headlight. It has two different intensities. Your headlight bulb on low beam is like this bright. On high beam, it's this bright, but they don't burn at the same time. When you flip your high beam, or your low beam to high beam, your low beam bulb goes off. Your high beam bulb is now on. Well, your turn signals, if they also serve as running lights, are dual elements. They're on down here as marker lights all the time when the ignition switch is turned on so people can see you. But then when you flip your left turn signal switch, the other side of it gets brighter. Alright? Same thing on the right side, or however you're looking at this, but this is my right. Your brake light assembly is a dual element bulb. It's got one that stays on all the time as the marker light, and then it has another one that lights up anytime you hit your brake light switch. And get this, you got two brake light switches. Ugh. Didn't think about that, did you? Well, how many brakes do you have on your bike? You got a hand brake, you got a foot brake, separate pedals. So you have to have wires for each one of those. Make sense? I hope so. Before we move on and unbox the new set, I did want to point out something to you. I don't know if you can see this or not. The speedometer is held to the speedometer mount by two bolts. Well, somewhere down the line, I guess somebody lost a clip and they chose to weld the mounting stud to this one and put a bolt in on that side. So we're going to have to deal with this. And this is rubber. I really don't want to take a torch to it. So what we're probably going to do is give Linda the Dremel with a grinding stone or a cutting wheel and let her see if she can take that off. Once we figure it out, we'll video that so you can see it. We're also going to try to get another speedometer for this one, because I've been led to believe that this is not the factory speedometer for the bike, and the owner would like an OEM speedometer in it if we can. So this is our Pro 1 wiring harness. It's called a dash base with wire harness, but a lot of people in the motorcycle world refer to it as a builder's harness, because although it'll fit many different bikes, it's somewhat universal, but at the same time it's not. Opening it up, and I've already taken it out, but if you order one of these, right here in the back you'll find your instructions, and it's pretty neat. I'll take pictures of these so you can see close-ups, but it's basically the front loom and the rear loom, and it'll show you the colors coming out of the looms and what they tie into. For example, right here, the black and white is the horn out, but it actually ties into the yellow wire coming out of the left control. That's important to know. I was really impressed with the way that this was packaged. For $200, I wasn't sure what I was going to get, but I was pretty happy with it. Comes with a new set of keys for the ignition switch, and in here, nicely wrapped, nicely protected, is the new wiring harness. And there she be. So, you know, anytime that you're working on something and this can be a tech tip, make sure before you start the install that what you're working on is what you're supposed to have. Lay them down and take a look at them. So what's the difference? What do you see? Well, the obvious difference is this aluminum metal plate here. And I'm afraid that the name of it, the specific name of it, escapes me right now, but this one doesn't have one. This one may have had one in the beginning, but it doesn't have one now. Based on my research, this one had some type of old leather strap on it that Harley put on it. I'm not real sure if that's true or not, but based on my research, factory one did not have this. And you're like, well, why are you telling me this? You know, what's the big deal? Why is that so important? Well, it kind of is, and here's why. Linda, see if you can find me my little pick. Over here, the bolts come in from the top. They pass through part of the bracket. We got a bracket right here. And then they got spacers on them. Well, the spacers on the back are a little bit longer than the ones on the front. And that's kind of cool. Here's why. Because they're about a 1/4 inch longer. Can they see that? Here, I can move it over. I'll move this over. How about right there? All right. How about right there? All right. So the front spacer is about a 1/4 inch shorter than the two spacers in the back. All right. Again, are you figuring out why this is important? All right. Let me just go ahead and cut to the chase. We're going to have to reverse these bolts because these threaded ends of these bolts screw in to the frame. So these bolts have to be turned around. Are you getting where the problem is yet? All right, well, that spacer's pretty much dead on with that one. That one's not quite dead on. It's about a 1/16 of an inch too long. But look here, sports fans. If you measure the distance from the top of the bolt head to the bottom of the spacer, because remember, this bottoms out against the frame, we're looking at about 2 1/8 of an inch. Okay? You let go, Lemon. Hold this one right here. If we flip this around and measure from the top of the bolt head, which is actually the nut head, now we're looking at 2 1/4 inches to the bottom of the aluminum. So if we just flip these around and mounted them on the bike, this is going to ride about 1/8 of an inch higher than this one did. You can say to yourself, well, is 1/8 of an inch that important? It is. Because I can tell you from working on this bike before, where this mounts into the frame and then the tank wraps around it, and then you have the chrome dash cover that goes over it, that chrome dash cover just snugs to where it's supposed to be. I think that if we left this, if we just mounted this one the way it is, I think this would ride too high and the chrome piece would not tighten down on the tanks to give it a good solid look. So what we're going to do is we're going to get some spacers, because I don't want to screw with these just yet. I'm still wanting to make sure that this is going to work, but I wanted you guys to see this today. And we're going to replace these fancy spacers with some of these spacers right here. And I don't want to tear these up in case we have to go back and use these. Does that make sense? All right, so we got our front spacer and we got 2 rear spacers. And through technology, we took off to the hardware store and came right back. We got spacers that were as closest to, or dead on to our inside diameter as we could, while being too long. And what we're going to end up doing is taking these 2 and trimming them down to the necessary height to replicate the ones that were on there. We're going to flip these. Can they see this? We're going to flip these bolts around. We're going to put these where they need to be in here, allowing for the extra 1/4 inch here. To make up for this 1/4 inch space down here, we're going to have to cut these a 1/4 inch shorter than the factory ones. So we got our piece marked. The thing that you want to be careful about is marking it and then putting your hacksaw on it and then pulling it toward you for the first stroke. That first stroke, the back teeth will start a groove that when you go to push forward, it'll keep the blade in there, and that way it won't jump all over the place. And if you have to, once you get it where you think you got it at, use your fingers right here as a guide and just pull them all the way back. Use the full length of the blade. As you can see right there, can they see that, Linda? You got a nice starting groove, and then you just go back, pull it again. Use the full length of the blade. Don't press down too hard, and be careful how tight you put the stuff in the vise. Just let gravity work and pull the blade through it. Now, a couple of things. Once you get this down here and you're getting ready to get through on the other side, really take your time. Cut through it. Don't have to bend it off. You don't want to clean up a big burr with a file. There it goes. Now, don't force it through there. Just let it come down to the bottom there. Take it off. Now, one of the things that I did do here was, you'll notice that I put the seam down. I didn't put it up at the top because then I've got to start a hole, a cut on 2 different pieces. And I didn't put it on the side because it's likely to squish if you do it on the side. So I put it on the bottom where the 2 pieces met to reinforce themselves. And as you can see, I had it in there pretty tight, but it's still nice and round. All right, so we're going to pass this over to Linda, and Linda's going to show you how to clean up these burrs without taking anything off of the actual metal. Okay, so as you can see, we've got some burrs right here, and we're going to try to take those off. And what Linda's going to do is she's going to use a metal file, and there's a couple different ways you can do this. You can hold it out like this and take the file and run it over the edge. See how it's grabbing? And while you're doing that, you're rotating it. All right. Now check it with your thumb, see if it's still there. Okay. And this thing doesn't have to be perfect. You just want all the burrs off of it to make it nice and clean. As I mentioned before, the next step in doing this, whether we replace this speedometer with another speedometer or use this one, we're going to have to get this off. And as I outlined earlier, it looks like somebody tack welded on there. So Linda's going to fire up her Dremel, and we're going to try to get that off. And I think probably what we'll try is we might try this cutting tool here, this one or this one, maybe one of the grinding stones. So we're going to get Linda set up on that, and we'll see what works. Thought I saw it move. There it went. Good job. I think Linda's ready to take it out. Should just wiggle that, just like that. All right, got a wire. All right, hold on. Let's see what's in there. That is your wire that goes to your speedometer light, which is connected over here. Let's see if we can just pop that out. Should come out just like that. So there's your speedo light right there, and there you go. Go ahead and show it right here, Britt. And then flip it around, and right here in the back is where your speedometer cable goes. And speedometer light right there. As you can see, these two are not the, well, that's sort of the proper piece right there. Linda, see if you can manipulate that out. Alright, put it right here. So the way this mount is supposed to work is you have a little washer in there, and if you can look real carefully right here, there's a C-clip. There's a hole in there that a C-clip snaps on, and there's supposed to be a rubber bushing on here to help with vibration. There was no rubber bushing on either. Well, God, there's something right there, but it's all compressed, and it shouldn't be compressed. Okay, so it's Saturday. Our pins have come in. This is a Drag Specialty speedometer mounting pin kit. Basically, it has 2 pins, 2 bushings, and 2 C-clips right here that I'll show you pictures of. And we don't have the wiring harness dash kit on the bike because it's just going to be easier to shoot it this way and let you see what we're doing. But we got our new spacers in there. They seem to be working good. And once we get the speedometer mounted onto the speedometer mount with the new pins and bushings, then we'll give it a test fit. So as you can see here, you have these 2 clips, and what these pins are going to do is they're going to slide in around this rubber mount that's flexible, and I guess it's like a weatherproofing, maybe an anti-rattle device. But we're going to put our pins in from the bottom, and then we'll put our bushings on, and then we're going to mount that right in here, and then we'll put our clips on the other side. So you have your pins with a little notch here, you have your bushings that slide on here, and then once this passes through the mount for the speedometer and into the mount on the dash, these little C-clips will line up with those 2 grooves, and sometimes you can squeeze them. If not, a small pair of needle nose pliers works best. And all we're going to do is put it on one side of the pin, on the other side of the C-clip, and snap it in. Can they see that, Linda? And that's it. That's all that holds the speedometer to the mount. And the whole idea is that when you put this through the mounts on the speedometer and through the hole on the speedometer dash mount, this compresses and keeps it from rattling. To get them off, you just take a little screwdriver, wedge it in there, and pry it off through those 2 little holes, and then you're back to step 1. You got your mount here. You got your mounts on the Speedo. Basically what we're going to do is take these, set them up, push the rubber back, set them in the hole, and compress them a little bit so the rubber holds each one of them. So now those are set. I'm trying to figure out the best way to show you how this is going to work. So let's try this. So we're going to take this, we're going to lay it over. Don't think this is going to be easy because it's not. So we got a C-clip ready. Can they see this right here? Have our little needle nose pliers. We're going to push down on this to expose that C-ring. And forgive me because I'm doing this backwards. And there it is. Now that one's mounted. We're going to go ahead and do the other one, and then we're going to do a test fit. So the Speedo's in the mount. Now we're going to take off these nuts. Now when you get down to the last nut, if you're doing this, make sure you hold this here so it doesn't all fly apart. So you're going to bring this up. You're going to put one loom on this side of the bike, one loom on this side of the bike, just to keep it balanced. And then what we'll do, now keep in mind, this would go a lot easier if the speedometer was off, because then we could access the bolt heads. Be careful not to cross your threads going in. get one started, and then you can come back here. Hold that. That's it. Get the other one started, and then get this one started. Ratchet wrenches are great. You can use that as a little tech tip if you want to. Ratchet wrench, open end on one end, ratchet on the other. You reverse it to go the other way. There we go. Alright, test fit looks good. She's in there solid. This is in there a lot tighter than it was. Now, I'm not going to snug these down because I'm going to take these back off, because I wanted to wrap up this part of the video by showing you how these bushings mounted and how everything in here seems to be fitting correctly. This bolt up here did bottom out, the matching ones. So what we're going to have to do is go back with the original bolt up here, which was about a ½ inch shorter. And other than that, it's in there and it looks good. I've said this before, I'm going to quit saying it. Trying to keep these videos short, but guess what? Some of this information just has to be shared. Alright? This video series is not for a master mechanic. This is for a guy who works out of his garage on the weekends and likes to play with motorcycles and drink beer. So sometimes the situation goes long because there's some information that you're going to have to be in there. We're going to try to keep this video in 2 parts. It may stretch out to 3. I don't know. We'll just have to see. But as I've been saying, check out the website. Take a look at the other videos. Take a look at the Facebook page that I created. Again, without preaching, without beating you in the head over it. But sometimes this is the first video that people find. Facebook is a much better platform to have a discussion than YouTube. So find the Facebook page, give it a like. If you have any questions, post your comment there. I don't know everything. I don't trust people who say they know everything. But there's a lot of people out there that know a lot about a little. And that's where we're at right here. So you ask a question, you're going to get my input on how to do it, and you're going to get Joe Smo's input on how to do it. And then you can choose which one of those you want to follow, or a combination of both, and then you learn something, and then you can come back to the Facebook page, and then you can help somebody else. Okay, so that's going to wrap this one up. I appreciate you guys coming by. Rate, comment, share the video, and we're going to move on to part 2 of this video. And